You know, it's so easy to think of machine learning models as these mysterious black boxes, right? You put data in, something happens, and an answer comes out. But what if I told you they're actually more like high-performance engines? And you, yes, you can be the mechanic who tunes them for absolute peak performance. Okay, let's dive in.
So is it all just magic? You just hope for the best? Not even close. The reality is so much more interesting and honestly, a lot more controllable than you might think. The real magic isn't in the box itself. It's in how we decide to set it up from the very beginning.
And this right here, this hits the nail on the head. The best models aren't just used, they are carefully tuned. They have these secret knobs and dials that we, the practitioners, get to adjust before we even turn the key. And learning how to master these settings is what really separates a decent model from a truly game-changing one.
So here's our blueprint for today. We're going to uncover what these secret knobs really are. Then, we'll meet a super powerful model called Random Forest, find out what its superpowers are, see how we can tune its rules, and finally, understand why it's such a reliable partner for solving really tough problems.
All right, let's get right into it with the model's blueprint. Those secret knobs we've been talking about, well, they have an official name: hyperparameters. Think of them as the foundational rules that literally guide how the model is going to learn and behave.
Now, the most important word on this slide, the one you absolutely need to remember, is before. See, a hyperparameter isn't something the model learns from the data. No, it's a choice that we make. It's a rule we set that tells the model how to learn, which basically defines its entire structure from the get-go.
Here's a great way to think about it to make it stick. Hyperparameters are like the recipe you choose before you start baking. You decide the oven temperature, how much flour, how long to bake it. The model parameters, that's the cake actually rising in the oven. It's the result of the process, something that's learned during training. You control the recipe, but the data and that recipe together determine how the cake turns out.
Okay, so if we're the ones setting these rules, you might be asking, why spend so much time fiddling with them? Well, this process, which we call tuning, is absolutely critical. It's what takes a model from being just meh to being outstandingly accurate and reliable.
And here's the why in a nutshell. First, tune-in directly boosts performance. And we're not talking about tiny little improvements. This can be the difference between a model that's 70% accurate and one that's 95% accurate. Second, it helps us find that Goldilocks zone, avoiding the twin dangers of overfitting, where the model just memorizes the data, and underfitting, where it's too simple to learn anything useful. And finally, good tuning makes our model stable and robust, so we can actually trust it to work out there in the real world.
Okay, theory is great, but let's see how this all works in practice. We're going to look at a really powerful and popular model that's just a perfect case study for this, the Random Forest. And to really get what makes it so special, we're going to use a simple, but I think really powerful analogy.
Instead of thinking of Random Forest as a single genius trying to solve a problem, I want you to picture it as a whole committee of specialized experts. You know, a single expert, or in this case, a single decision tree, might have its own biases, it might make a mistake. But if you get a big committee of hundreds of diverse experts together and just take their collective vote, the final decision becomes incredibly stable, super robust, and way more accurate. That's the big idea behind Random Forest.
Now, this whole committee structure gives Random Forest some serious advantages. We can think of them as its superpowers. The first one is its incredible knack for handling data with really complex, messy structures and relationships.
So what does that actually mean? Well, it handles high-dimensional data. That's just a fancy way of saying you have way more features than you have examples. It also captures complex, non-linear patterns, so think zigzags and curves, not just simple straight lines. And it's great at multi-class problems, where the answer isn't just a simple yes or no, but could be one of many different options. And that strength in complexity leads directly into its second superpower, its toughness when dealing with the kind of imperfect, messy data we always find in the real world. This is where that committee's resilience really shines.
For starters, it has clever, built-in ways to handle missing values, so it doesn't just crash and burn. And here's where the committee analogy is perfect. By averaging hundreds of opinions, it resists outliers. A single loud, incorrect expert in the room, they just get outvoted by the quiet consensus of everybody else. This structure is also fantastic for preventing that overfitting problem we talked about, making sure the model actually learns patterns instead of just memorizing the past.
But all that power and robustness would be pretty useless if it wasn't practical to use, right? And that brings us to Random Forest's third key superpower.
It's incredibly user-friendly and efficient, and that is a huge deal for any team working against the deadline.
One of its best features, honestly, is that it often gives fantastic results right out of the box with its default settings, which can save you a ton of time. It also gives you something called feature importance, which is basically a ranked list of what factors mattered most in its decisions. It's like the committee chair telling you exactly which pieces of evidence were the most critical. And on top of all that, it's efficient. You can split the work up across multiple processors, which speeds up training time in a big way.
Now, even though Random Forest works great with minimal fuss, let's bring it all back to our main theme. We can still tune it for peak performance. You know, even the best committee operates under a set of rules, and with Random Forest, we are the ones who get to set those rules.
Let's look at the 3 most common knobs we can turn, using our committee analogy. First up, N estimators. This is simple. It's how many experts you want on your committee. More is often better, but it takes more time. Second, max depth. This controls how deep or complex each individual expert's reasoning can get. Too deep and they might start overthinking things. And third, min sample split. This is like setting a ground rule for how much evidence an expert needs before they're even allowed to form an opinion.
But here is the real kicker with Random Forest. While tuning can definitely squeeze out that last bit of performance, one of its greatest strengths is that it's less sensitive to these settings than a lot of other complex models. It gives you a strong, reliable baseline result really quickly, and that is just incredibly valuable.
So when you pull all of this together, you start to see Random Forest as not just a prediction tool, but as a truly reliable strategic partner. It's built from the ground up to handle the messiness of real-world data and give you insights you can actually do something with.
And this is where it all comes together. Remember that feature importance superpower? This is what it actually looks like. The model doesn't just tell you what it predicts, it tells you why. So in this example, it's screaming that recent purchases are the #1 driver of its prediction. This is what turns a black box into a glass box.
So the value proposition is pretty clear, right? It's robust enough for messy data. It's powerful enough for complex problems. It's efficient enough for tight deadlines. And it's transparent enough to turn a prediction into real, data-driven action. It's a true workhorse for any modern data science team.
We've seen that machine learning isn't magic, it's engineering. It's all about building a powerful committee of experts and then giving them the right set of rules to succeed. So the final question I'll leave you with is this. Now that you know about these secret knobs, which rules are you going to set for yours?